Welcome to an installment of CCSD Living Environment. Today we're going to talk about pyramids of energy and biomagnification or bioaccumulation. In the last video, we talked about trophic levels, feeding levels, and what happens as you move up the food chain. What we said was that energy is lost as you move up. So the idea behind that is each consumer only stores about 10% of its ingested nutrients. This is the food for the next feeding level. The remaining energy, which is about 90%, is lost in the form of heat from cellular respiration and unavailable chemical energy. So sure, 100% of that energy from the sun the plant may have, but when the deer eats the grass, it only gets 10%. And the human only gets 10% of the 10% when they eat the deer. So each time you take a step up, you're losing energy. Well, where does that energy go? We can't just lose energy. We've said that before. Well, it comes off as heat energy from respiration, or it's just not available to be used. We just can't use that energy. So how do we represent that loss of energy, or how do we represent this energy moving up a food chain? We use something called a pyramid of energy. In a pyramid of energy, it's used to demonstrate the loss of energy at each feeding level. The total amount of energy found in food is greatest at the producer level and decreases with each consumer level. So if we start off at the bottom with our producers, our autotrophs, our photosynthetic organisms, they have the most energy of anything in the whole ecosystem. And each step that we take as we move up, each time we increase, we lose energy, we lose energy, we lose energy. So we kind of did the whole grass, mouse, snake ecosystem or food chain last time. This time let's switch and go to a water ecosystem. So if I start with my algae, which would be my producers or photosynthetic organism, and I move up to water fleas, the water fleas are eating the algae. The water fleas have less energy. The minnows are eating the water fleas. The minnows have less energy than the water fleas. The bass are eating the minnows. The bass have less energy than the minnows. So again, if the water fleas get 10% from the algae, the minnows get 10% of that 10%. And then the bass would get 10% of the 10%. So by the time you reach the top of the food chain, there's not a lot of energy left. You've really depleted the amount of energy that's in that food chain, that's in that ecosystem. And that's why we keep saying the amount of energy for the ecosystem is completely based on the amount of energy produced by your producers, by your green plants, by your algae, by your photosynthetic organism, by your autotrophs. They really determine the energy for the entire food chain, for the entire ecosystem. Another way to look at that is if we talk about a pyramid of numbers. We're all familiar with pyramids. And when I mention a pyramid to you, either you think about something from cheerleading, or maybe you've done one with your friends, maybe you've watched a show on ancient Egypt. You have this idea of something being very wide at the bottom and very skinny at the top. Well, a pyramid of numbers, you're going to have a lot at the bottom and fewer on top. The pyramid of numbers, the number of organisms decreases as you move up the pyramid. No big surprise. So if I had 100 at the bottom, my next level might have 75, 50, 25. I've decreased my number as I've moved up. That's the pyramid of numbers. That number could be equivalent to the amount of energy, and that amount of energy is decreasing as you move up the pyramid, as you move up the food chain. Another way to look at that is with the pyramid of biomass. Now again, remember, bio means living. So the pyramid of living mass, well, that would exclude dirt and rocks and water. The important thing to keep in mind about biomass is that it's the total dry mass of all the organisms. Because if I told you that all the organisms in an ecosystem, the carnivores weigh less than the producers, and you're going to argue that with me and say no, because a lion weighs more than grass. Well, that may be true, but if we use the dry mass, and you take all of the producers in that ecosystem, even if you take all of the lions in that ecosystem, all of those producers' dry mass is going to be more than the lions. So at that point, you should be asking yourself a question. Is it really best to be at the top of the food chain? Is it truly the best place to be? And I'm hoping after the last couple videos, your answer to that question is no. It really is not beneficial to be at the top of the food chain. You don't have as much energy. You're definitely lacking where the producers down at the bottom have what they need. They're not dependent on anybody. So let's pull from Kermit the Frog here and say, yeah, it really is kind of great to be green. Because for green plants and algae, that green allows them to make their own food. It allows them to be photosynthetic. And really, they have the control over the entire ecosystem. So the plants really do matter. Now in your note packet, you have a picture that looks like this. And if you look at that picture, it shows you the pyramid of energy, the pyramid of numbers, and the pyramid of biomass. And it gives you an example for each one. And it's showing you that at the bottom, you have the most organisms. The population is the largest. Each time you take a step up, that gets smaller and smaller and smaller. It gets skinnier and skinnier and skinnier if you're looking at the pyramid. So really, as we move up, the population is smaller, the energy requirement is actually larger, but you're not getting as much energy. And that's a really tough thing for organisms to try to accommodate. So here's what I want to do. I want to have you think for a minute. As you move up the food chain, what happens? The amount of energy decreases. Very good. Now we need to switch gears just a little bit. And there's another concept that I want to look at. That concept is called biomagnification or bioaccumulation. With biomagnification, the process where the concentrations of pollutants or toxins increase at higher trophic levels in a food chain. So now we're talking about something completely opposite. We have kind of beaten into you at this point that as you move up the food chain, as you move up the pyramid, the amount of energy decreases. Less energy, less energy, less energy. So by the time you hit the top of the food chain, your energy amount is very low. We're not talking about energy anymore. We're talking about pollutants or toxins. And what this is telling you is each time you move up the food chain, the amount of pollutants or the amount of toxins increases. This is kind of a scary thing. This is why they tell you you shouldn't eat a lot of fish. Unfortunately, there's mercury in a lot of our freshwater systems. And when you catch the bass, you catch the perch, and you eat them, you're taking those toxins into your system. And since you're a higher point in the food chain, you have more of that toxin than the bass or perch or trout that you ate. So if we start with the water, in the water there's a very small amount of the toxin. This is 0.00003 parts per million. Parts per million is a unit that we use to measure. The plankton, which are the photosynthetic ones, 0.04 parts per million. Still low, but it's more than what there was in just the plain water. Because remember, for a photosynthetic organism, water was one of the raw materials they needed. Small fish, 0.5 parts per million. You say, well, 0.5 isn't very big. Well, it is compared to where we started with the water. And then when we move to large fish, I'm at 2 parts per million. So it's increasing pretty dramatically. By the time I hit eagles and osprey and potentially other aquatic birds, I'm at 25 parts per million. That's a huge amount. This is going to wreak havoc on the systems of those birds for multiple reasons. Now, we mentioned mercury. There's another really classic example of biomagnification in the United States. We don't like insects. We don't like mosquitoes biting us. I think we could all agree on that. Well, at one point along the way, they had a product on the market called DDT. And what DDT did was killed insects. It was an insecticide. So they sprayed it, killed the insects, everybody was happy. Well, the populations of osprey and peregrine falcons and some other birds was decreasing dramatically. Any birds that lived next to an aquatic source. So the question became why? Why was that happening? Well, upon some investigation, what they learned was that DDT was actually taking the eggshells of those birds and making them very soft, making them to the point where they couldn't reproduce. So yeah, the birds would mate and they'd lay the eggs, but then the chicks weren't hatching. And it was because of the fact that the DDT had an effect on the eggs. So the populations of those birds decreased dramatically over the course of a few years. And so what they finally said was, no more DDT, we're done with this. And so in the early part of the 70s, they actually banned DDT, and they banned the use of DDT in the United States. Now, the populations of osprey and peregrine falcons has rebounded. It's come back. But had they not stopped using DDT, I think the populations of those birds would no longer be here. So it's kind of an oversight, but unnecessarily so. And something we learned from it, the very important thing that we learned from it, is this concept of biomagnification. Biomagnification is the opposite of energy in a food chain, because with biomagnification, you know magnification means to make it bigger. With biomagnification, as you move up the food chain, as you move through the living parts of the ecosystem, at each step along the way, you get more and more and more and more of that toxin in the ecosystem. And it does a lot of destructive damage. I hope you've enjoyed the video today on energy pyramids and biomagnification. Have a good day.